These ML concepts confuse even experienced data scientists. What is the meaning of number of epochs in machine learning? Answer: in machine learning, the number of epochs refers to the number of times an algorithm passes through the entire training dataset to learn and improve its performance. Each pass is called an epoch, and the algorithm adjusts its parameters and weights accordingly. The number of epochs determines how many times the algorithm will see the data and make adjustments, which can affect the accuracy and convergence of the model. A higher number of epochs can lead to overfitting, while a lower number may not allow the model to learn well enough. The optimal number of epochs depends on the specific problem, dataset, and algorithm being used. What is batch size in machine learning, and how does it affect the training process? Answer: batch size is the number of samples that are processed together by the algorithm during training. For example, if you have a dataset with 1,000 records and set a batch size of 100, the algorithm will process 100 records at a time, then move on to the next 100 records, and so on. This approach allows the algorithm to learn from a smaller subset of the data at a time, which can be beneficial for large datasets. A larger batch size can speed up the training process, but may also lead to overfitting if the model is not regularized properly. On the other hand, a smaller batch size can help prevent overfitting, but may slow down the training process. The optimal batch size depends on the specific problem, dataset, and model being used. What is momentum in the context of machine learning, and how does it help during the training process? Answer: momentum is a learning rate adaptation technique that adds a fraction of the past update vector to the current update vector. This helps to dampen oscillations and speed up progress towards the minimum. In other words, it allows the model to learn from its previous updates and adjust its learning rate accordingly, which can lead to more stable and efficient training. This is particularly useful when dealing with non-convex optimization problems where the model may get stuck in local minima. By incorporating momentum, the model can escape these local minima and converge to a better solution. What is the primary focus of optimizers in machine learning, and how do they achieve this? Answer: the primary focus of optimizers in machine learning is to get the learning rate right. This is because the learning rate determines how quickly the model learns from the data. A decode optimizer achieves this by using a large learning rate for infrequent features and a smaller learning rate for frequent features. Other optimizers, such as a delta, RMS prop, and Atom, make further improvements by fine-tuning the learning rate and momentum to get to the optimal weights and bias. By getting the learning rate right, these optimizers help to train well-performing models. What is the learning rate, and how does it control the update of weights and bias terms in a neural network? Answer: the learning rate is a hyperparameter that determines how much the weights and bias terms W plus B are updated after training on each batch. A high learning rate can cause the model to overshoot the optimal solution, while a low learning rate can cause the model to converge too slowly. The learning rate helps to balance the trade-off between exploration and exploitation, allowing the model to adapt to the training data and make progress towards the optimal solution. Several helpers, such as the Atom optimizer, are used to get the learning rate right, as it is a crucial component in the training process of a neural network. What is the purpose of using skip/residual connections in the neural network? Answer: skip/residual connections are used in a neural network to alleviate the vanishing gradient problem that occurs when training deep neural networks. This problem occurs when the gradients of the loss function with respect to the weights of the earlier layers become smaller as they are multiplied by the weights of the later layers. Skip/residual connections allow the gradients to flow directly from the output layer to the earlier layers, allowing the network to learn more complex and deeper representations of the data. This is achieved by adding the input of a layer to its output, effectively skipping the weights and biases of the layer, and allowing the gradients to flow directly from the output to the input. This helps the network to learn more robust and accurate representations of the data. What are the advantages of using ReLU or leaky ReLU activation functions over sigmoid and tan in deep neural networks? Answer: ReLU rectified linear unit and leaky ReLU are more popular choices than sigmoid and tan in deep neural networks because they have several advantages. Firstly, ReLU and leaky ReLU are much faster to compute than sigmoid and tan, which makes them more suitable for large-scale neural networks. Secondly, ReLU and leaky ReLU are less prone to vanishing gradients, which is a common problem in deep neural networks where the gradients become very small as they are propagated backwards. This is because ReLU and leaky ReLU do not have the same saturating behavior as sigmoid and tan, which means that the output of the activation function does not approach zero as the input increases. Finally, ReLU and leaky ReLU are more robust to outliers in the data, which is important in many real-world applications. Overall, ReLU and leaky ReLU are more efficient, stable, and robust than sigmoid and tan, making them popular choices in deep learning. What are some reasons why the loss doesn't decrease in a few epochs during the training of an artificial neural network? Answer: some reasons why the loss doesn't decrease after a few epochs are that the model is underfitting the training data, the learning rate is too large, the initialization is not proper, the regularization hyperparameter is too large, or there is a vanishing gradient problem. When the downstream task has limited data, what can we do to improve the model's performance? Answer: when the downstream task has a very small amount of data available, we can try using pre-trained model weights by switching the last layer with new layers that we will train. This approach allows us to leverage the knowledge gained from the pre-trained model and adapt it to the specific task at hand, even with limited data. By doing so, we can improve the model's performance and make better predictions. When can a pre-trained model's initial layers not be used directly in transfer learning, and why? Answer: a pre-trained model's initial layers cannot be used directly in transfer learning when the tasks are significantly different, requiring unique features to be detected. For example, in vision-related tasks, the initial layers may detect edges, but in a language model, the initial layers may detect phonemes or morphemes, which are not applicable to the new task. In such cases, the model needs to be fine-tuned to adapt to the new task, and the initial layers may not be sufficient. This is because the initial layers are trained on a specific dataset and may not generalize well to a new task with different requirements. Is the cost a primary consideration when evaluating a technology, and can we achieve similar performance without incurring the cost? Answer: yes, the cost is a crucial factor to consider when evaluating a technology. It is essential to determine whether the benefits of a technology outweigh its costs. If the cost is prohibitively high, it may be more cost-effective to explore alternative solutions that can provide similar performance at a lower cost. By considering the cost, we can make informed decisions about whether to invest in a particular technology or not. Why does the pre-trained model have no relation to the downstream task? Answer: the pre-trained model has no relation to the downstream task because it was trained on a different dataset or objective, which is not directly applicable to the downstream task. This means that the model's knowledge and skills are not tailored to the specific requirements of the downstream task, and it may not perform well on that task. In other words, the pre-trained model is not specialized for the downstream task, and its performance may be suboptimal as a result. If latency is a significant constraint in NLP, is transfer learning a suitable option? How has this limitation been addressed with recent advancements in platforms and model distillation? Answer: transfer learning is not the best option when latency is a big constraint in NLP. However, with the advent of platforms like TensorFlow Lite and model distillation, latency is no longer a problem. This means that transfer learning can now be a viable option even in latency-constrained scenarios. What is the purpose of the forget gate in a recurrent neural network RNN? Answer: the forget gate in a recurrent neural network RNN is responsible for deciding which data to keep or throw out. It helps the network to selectively forget or remember information from previous time steps, allowing it to learn and adapt to new information while also retaining important patterns and relationships. This gate plays a crucial role in preventing the network from getting stuck in an infinite loop or losing track of important information over time. By controlling the flow of information, the forget gate enables the RNN to learn more effectively and make more accurate predictions. What is the purpose of the input gate in a long short-term memory LSTM network? Answer: the input gate in an LSTM network helps determine whether new data should be added to the long-term memory cell based on the previous hidden state and new input data. It acts as a filter, deciding what information to let in and what to keep out, allowing the network to selectively update its memory. This process enables the network to learn and remember relevant information over time. What is the function of the output gate in a recurrent neural network RNN? Answer: the output gate is responsible for generating the new hidden state of the RNN. It takes the current temporal state, input word or observation, and the previous hidden state output as inputs, and applies sigmoid activation to produce the new hidden state. This gate plays a crucial role in the RNN as it determines the output of the network and affects the flow of information throughout the network. How would you change a pre-trained neural network from classification to regression? Answer: we can use transfer learning, where we can use our knowledge about one task to do another. First set of layers of a neural network are usually feature extraction layers and will be useful for all tasks with the same input distribution. So, we should replace the last fully connected layer in softmax responsible for classification with one neuron for regression, or fully connected layer for correction, then one neuron for regression. We can optionally freeze the first set of layers if we have few data or to converge fast. Then we can train the network with the data we have and using the suitable loss for the regression problem, making use of the robust feature extraction first set of layers of a pre-trained model on huge data. What is the effect of rescaling by gamma and shifting by beta on the mean and standard deviation of a distribution? Answer: rescaling by gamma and shifting by beta helps us change the mean and standard deviation to other values. This is because rescaling by gamma changes the standard deviation by a factor of gamma, and shifting by beta changes the mean by beta. This is a useful technique in statistics and data analysis, as it allows us to transform data to have a desired mean and standard deviation. What is the purpose of disabling a layer during validation and testing in deep learning? Answer: the purpose of disabling a layer during validation and testing in deep learning is to reduce the complexity of the model and prevent overfitting. This layer is only enabled during training, which makes the model simpler and faster, allowing for faster validation and testing. Once the model is trained, it doesn't make sense to keep the layer enabled, as it would add unnecessary complexity. This approach ensures that the model is not overfitting and provides more accurate results. What is the advantage of deep learning models in processing large amounts of data? Answer: deep learning models can analyze and process massive amounts of data quickly and accurately, making it ideal for tasks such as image recognition or natural language processing. This is because they are designed to handle large amounts of data and can learn patterns and relationships in the data, allowing them to make accurate predictions and decisions. This ability to process large amounts of data makes deep learning models particularly useful in applications where data is abundant, such as image and speech recognition, natural language processing, and recommender systems. What is the main difference between traditional machine learning and deep learning in terms of feature extraction? Answer: in traditional machine learning, feature engineering is a crucial step where humans manually extract relevant features from raw data. In contrast, deep learning models can automatically learn and extract features from raw data, reducing the need for human intervention. This automation enables deep learning models to learn complex patterns and representations from data without requiring extensive feature engineering. What is the main advantage of deep learning models over traditional machine learning models in terms of accuracy? Answer: deep learning models have been shown to achieve higher accuracy levels in complex tasks such as speech recognition and image classification compared to traditional machine learning models. This is because deep learning models can learn and represent complex patterns and relationships in data more effectively, leading to better performance in tasks that require nuanced and subtle distinctions. What is a depth-wise separable layer and what are its advantages? Answer: a depth-wise separable layer is a type of convolutional layer in deep learning that separates the depth-wise and point-wise operations, reducing the number of multiplications required. This makes it more computationally efficient and suitable for deployment, especially when dealing with large input images. The advantages of depth-wise separable layers include reduced computational complexity, memory usage, and improved performance on mobile and embedded devices. This is achieved by breaking down the traditional convolutional layer into two separate operations, depth-wise convolution and pointwise convolution. Depth-wise convolution applies the same filter to each channel of the input, while pointwise convolution applies a one-sum convolution to combine the output of the depth-wise convolution. This approach reduces the number of parameters and computations required, making it a more efficient and scalable solution for deep learning models. How does depth-wise separable convolution reduce the number of multiplications required in a standard convolution operation? Answer: depth-wise separable convolution separates the standard convolution operation into two parts, depth-wise convolution and pointwise convolution. In depth-wise convolution, 3 facts of x and kernels move x 8 times, resulting in 4,800 multiplications. In pointwise convolution, 256 functions 3 kernels move x at times, resulting in 49,152 multiplications. This reduces the total number of multiplications from 128,800 in standard convolution to 53,952, making it a more efficient operation. What is the primary function of an encoder in a neural network? Answer: the primary function of an encoder is to process the input sequence, such as a sentence or a document, and transform it into a set of representations that capture the contextual information of each input element. This means that the encoder takes in a sequence of words or characters and generates a set of vectors that represent the meaning and relationships between the elements in the sequence. The encoder is a crucial component in many natural language processing tasks, such as machine translation, text summarization, and language modeling. What is the role of the decoder in a transformer model, and how does it generate an output sequence? Answer: the decoder is responsible for generating an output sequence based on the encoded representations generated by the encoder. It consists of multiple identical layers, each containing a self-attention mechanism and additional cross-attention mechanisms. The cross-attention mechanisms allow the decoder to focus on relevant parts of the input sequence when generating the output. This enables the model to predict the next word or token in the output sequence, taking into account the context provided by the input sequence. In essence, the decoder uses the encoded input to generate the output sequence, one token at a time, by attending to relevant parts of the input and generating the next token based on that attention. What is self-attention in the context of the transformer model? Answer: self-attention is a mechanism in the transformer model that allows it to weigh the importance of different elements in the input sequence when generating representations. It does this by computing attention scores between each element and every other element in the sequence, resulting in a weighted sum of the values. This process enables the model to capture dependencies and relationships between different elements in the sequence, allowing it to better understand the input data. What is the purpose of positional encoding in transformers, and how does it help the model understand the input sequence? Answer: positional encoding is a technique used in transformers to provide information about the order or position of elements in the input sequence. This encoding is added to the input embeddings, allowing the model to understand the sequential nature of the data. In other words, it helps the model understand that the input sequence has a specific order, which is essential for tasks like language translation, text summarization, and more. This encoding enables the model to capture the relationships between elements in the sequence, making it a crucial component of transformer architecture. What is the main difference between BERT and traditional language models? Answer: BERT differs from traditional language models in its ability to capture the context of a word by considering both the left and right context in a sentence. Traditional language models process text in a sequential manner, making it difficult to capture the full context, whereas BERT's bidirectional training allows it to capture contextual information effectively. This is achieved through pre-training on a large corpus of unlabeled text data, where BERT learns to predict missing words and sentences by considering the surrounding words on both sides. How does BERT improve language understanding by considering the context of words in a sentence? Answer BERT is able to capture the contextual meaning of words by considering both the preceding and following words in a sentence. This means that it takes into account the words that come before and after a word to understand its meaning, which leads to better language understanding. For example, the word bank can refer to a financial institution or the side of a river, depending on the context. BERT's ability to consider context helps it to disambiguate words like this and understand their meaning more accurately. This results in improved language understanding and better performance on language-related tasks. What is transfer learning in the context of BERT, and how does it benefit the model? Answer: transfer learning in BERT refers to the process of pre-training the model on a large corpus of unlabeled data, allowing it to learn general language representations. These pre-trained representations can then be fine-tuned for specific tasks, even with limited labeled data. This benefits the model by enabling it to learn from a vast amount of data, making it more accurate and efficient, and allowing it to adapt to new tasks with less training data required. What are some examples of natural language processing tasks that BERT can be applied to? Answer: BERT can be applied to a wide range of natural language processing tasks, including question answering, text classification, and more. This versatility allows it to achieve state-of-the-art performance in these tasks by fine-tuning the model on specific tasks. How does BERT's bidirectional nature help it handle ambiguous language constructs? Answer: BERT's bidirectional nature allows it to consider the context from both directions, which helps it to handle ambiguous language constructs more effectively. This means that BERT can take into account the words that come before and after a word, and use this information to make more informed predictions about the word's meaning. This ability to consider context from both directions helps BERT to disambiguate words and phrases that have multiple possible meanings, and to make more accurate predictions about the text as a whole. What is the purpose of pre-training a transformer model? Answer: the purpose of pre-training a transformer model is to enable it to learn general language patterns, syntactic structures, and semantic relationships by training it on a large corpus of unlabeled text data. This is done through two tasks: mass language modeling, where the model predicts missing words in a sentence, and causal language modeling, where the model predicts the next word in a sequence. This process prepares the model for downstream tasks, such as natural language processing and language translation. What is fine-tuning in the context of transformer models, and how does it work? Answer: fine-tuning is a process where a pre-trained transformer model is retrained on a specific downstream task with a smaller labeled dataset. The model's parameters are adjusted to optimize its performance on the new task, while the pre-trained knowledge serves as a strong starting point. This allows the model to adapt to the new task while still leveraging its existing understanding of language. In other words, fine-tuning helps the model learn task-specific details while building upon its pre-trained foundation. What is the benefit of pre-training a model on large unlabeled datasets? Answer: pre-training a model on large unlabeled datasets allows it to capture general language understanding, which reduces the need for massive amounts of labeled task-specific data. This means that the model can perform well on a variety of tasks without requiring a large amount of labeled data for each task. Instead, it can use its general language understanding to adapt to new tasks with less data. This makes it more efficient and effective in many situations. What is the benefit of pre-training a language model, and how does it enable the model to generalize well to new tasks and domains? Answer: pre-training a language model allows it to learn rich representations of language, which enables it to generalize well to new tasks and domains. This is because the model has been trained on a vast amount of text data, giving it the ability to understand language patterns, relationships, and nuances. As a result, when applied to new tasks or domains, the model can leverage its pre-trained knowledge to make accurate predictions and generate coherent text even if it has not seen the specific task or domain before. This improved generalization capability makes pre-trained language models highly effective in a wide range of applications. What is the advantage of fine-tuning a pre-trained model compared to training a model from scratch? Answer: fine-tuning a pre-trained model requires less computational resources and training time compared to training a model from scratch. This is because the pre-trained model has already learned general features and patterns from a large dataset, so it only needs to be adjusted to fit the specific task or dataset being used. This makes the training process more efficient and reduces the amount of time and resources needed to achieve good results. How can transformers be used for tasks other than natural language processing, such as computer vision? Answer: transformers can be used for tasks other than natural language processing, such as computer vision, by leveraging their ability to model complex relationships between data points. This is achieved through techniques like self-attention, which allows the model to focus on specific parts of the input data and weigh their importance. This ability to model complex relationships makes transformers a powerful tool for tasks like image classification, object detection, and image segmentation, where the relationships between different parts of the image are crucial for accurate prediction. By applying transformers to computer vision tasks, researchers have been able to achieve state-of-the-art results in many areas, demonstrating the versatility and effectiveness of transformers in a wide range of applications. What is horizontal flipping in image processing, and when is it useful? Answer: horizontal flipping is a technique in image processing where an image is flipped horizontally, meaning the left and right sides of the image are swapped. This is useful in tasks where the orientation of objects in the image does not affect their interpretation, such as object detection or image classification. This is because the objects in the image are still recognizable and can be detected or classified even after being flipped. This technique is particularly useful in situations where the image acquisition process or the environment in which the image is taken may cause the image to be rotated or flipped, and the algorithm needs to be robust to these variations. What is vertical flipping in image processing, and how does it differ from horizontal flipping? Answer: vertical flipping is a technique in image processing where an image is flipped from top to bottom, similar to how horizontal flipping flips an image from left to right. The main difference between the two is the direction in which the image is flipped. While horizontal flipping is commonly used to create mirror images or to improve image recognition, vertical flipping is less commonly used but can be useful in certain applications, such as creating a sense of symmetry or reversing the orientation of an image. What is the purpose of random rotation in image processing, and how can it be used to simulate real-world scenarios? Answer: random rotation. It is a technique used in image processing to rotate images by a random angle. This can be helpful to simulate real-world scenarios where objects are often viewed at different angles and orientations. By randomly rotating images, we can create more realistic and diverse datasets, which can improve the accuracy of machine learning models and enhance the overall performance of image processing algorithms. For example, in object detection tasks, random rotation can help the model learn to recognize objects from different angles, making it more robust and effective in real-world applications. What is the purpose of using random crops in the input images during training? Answer: the purpose of using random crops in the input images during training is to force the model to focus on different parts of the image, which helps the model to handle varying object scales. This technique is useful in object detection tasks where the object of interest may appear at different scales in the input images. By randomly cropping the input images, the model is trained to be more robust to object scale variations, which improves its overall performance. What is the purpose of scaling and resizing images in image augmentation, and how does it help a machine learning model? Answer: scaling and resizing images in image augmentation helps a machine learning model by allowing it to handle objects of varying sizes. This is achieved by rescaling images to different sizes or resizing them while maintaining the aspect ratio. This augmentation technique enables the model to learn features that are invariant to the size of the objects, making it more robust and accurate in real-world applications. By training the model on images of varying sizes, it can better generalize to new, unseen images with different sizes. This is particularly important in applications where objects can appear at different scales, such as in object detection and segmentation tasks. What is color jittering, and how can it benefit a machine learning model? And so color jittering is a data augmentation technique that randomly changes the brightness, contrast, saturation, and hue of images. This helps a machine learning model become more robust to changes in lighting conditions, making it more accurate and reliable in real-world applications. By exposing the model to a diverse range of image variations, color jittering enables it to learn generalizable features and improve its overall performance. What is the purpose of adding Gaussian noise to images in deep learning models? Answer: adding Gaussian noise to images in deep learning models simulates noisy environments and enhances the model's noise tolerance. This means that the model becomes more robust and can perform better even when the input images are corrupted with random noise. This technique is useful for training models that will be used in real-world applications where the input data may be noisy or uncertain. By training the model on noisy data, it learns to be more accurate and reliable in the presence of noise. What is elastic transformation, and how does it work in image processing? Answer: elastic transformation is a technique used in image processing to apply local deformations to an image, simulating distortions that might occur due to variations in the imaging process. This technique works by applying a set of transformations, such as scaling, rotation, and translation, to the image in a way that mimics the natural distortions that occur during imaging. The transformations are applied randomly and locally, creating a unique and realistic distortion pattern for each image. This technique is useful in applications such as image registration, image segmentation, and image enhancement, where the ability to simulate and correct for distortions is important. What is the purpose of cutout in image processing? Answer: cutout is a technique used to randomly mask out portions of an image with black pixels. This helps the model learn to focus on other informative parts of the image, which can improve its performance and robustness. By masking out certain areas, the model is forced to rely on other features and patterns in the image, making it more robust to variations in noise. This technique is particularly useful in image classification tasks where the model needs to learn to recognize objects despite variations in lighting, pose, and background. What is mix-up and how does it help in deep learning models for computer vision tasks?
Answer: mix-up is a data augmentation technique that combines two or more images and their corresponding labels in a weighted manner to create new training examples. This encourages the model to learn from the combined patterns of multiple images, which can help the model to generalize better and improve its performance on unseen data. By combining different images and labels, mix-up can help the model to learn more robust features and become less dependent on a single image or label. This can be particularly useful in computer vision tasks where the model needs to learn from a diverse set of images with different characteristics. For example, in object detection tasks, mix-up can help the model to learn to detect objects in different poses, sizes, and lighting conditions. Overall, mix-up is a powerful technique that can help deep learning models for computer vision tasks to learn more effectively from the available data.